we are not getting any kind of satellite imagery of what's happening with 3I Atlas.
From billion-dollar orbiters circling Mars to telescopes scattered across Earth, scientists wanted the clearest look yet at the interstellar comet known as 3I Atlas.
Look at that bad boy.
This is a raw image, so this is not even like, this is just directly from the telescope right now.
The timing was perfect. But then, every feed went dark. No close-ups, color, or structure. Just a broken pixelated image of the most controversial interstellar object.
3I Atlas, and that's definitely a risk that NASA takes seriously. And in fact, we have survey telescopes monitoring the sky for near-Earth objects.
Was this just a technical failure, or was this a deliberate attempt to make sure humans never got a clear look? Because if this was just a comet, why did it block every space telescope?
The problem is the image was taken on October 2nd. That's the day after the government shut down, and the claim is that because of the shutdown, NASA is unable to release the data.
The comet everyone was watching. On the morning of October 7th, 2025, the European Space Agency did what everyone had been waiting for. They released the first official images of the interstellar object known as 3I Atlas. This was a once-in-a-lifetime visitor, a rare object that had entered our solar system from deep interstellar space and was now skimming right past Mars.
This is 3I Atlas. This is Mars. 3I Atlas is about to swing by, and a fleet of camera-ready rovers and orbiters are standing by to snap some pictures.
Only two other interstellar objects had ever been confirmed: Oumuamua in 2017 and Comet Borisov in 2019, but neither of them passed this close to active spacecraft. This was the opportunity scientists had dreamed of, and everyone was watching. Every major observatory, every space agency, every telescope network, they were all waiting for the drop. But when the image finally came, it was not what anyone expected. Instead of a crisp, high-resolution capture showing jets, structure, or even a hint of a nucleus, ESA's official release was blurry, grainy, a faint smudge lost in the noise. Where were the sharp images? Why was ESA's billion-euro orbiter producing worse visuals than some backyard telescopes? NASA said nothing. China said nothing. The United Arab Emirates, with a spacecraft also orbiting Mars, released nothing. It wasn't just one agency missing the moment. It was all of them. The three most advanced space powers, with multiple instruments staring at Mars, all went quiet at the exact same time the world was expecting answers. And then the internet noticed something strange. Amateur astronomers began uploading their own captures of 3I Atlas, faint and noisy, yes, but clearer than what ESA had posted. Ground-based photos, some from school observatories and personal rigs, seemed to show more detail than billion-dollar missions orbiting the very planet it was passing. How was that possible? It didn't take long for suspicion to take root. The silence felt deliberate. The timing felt off. The more people looked at it, the more it started to feel like a cover-up. And once that seed was planted, it spread. This was supposed to be the comet's defining moment. 3I Atlas was making its closest approach to Mars, and for the first time ever, multiple orbiters were in position to catch it from space. ESA's Trace Gas Orbiter, NASA's Mars Reconnaissance Orbiter, China's Tianwen-1, the UAE's Hope Probe. Even the Perseverance rover and the Ingenuity helicopter were on the ground, all of them potentially in range. Never before had so many cameras, so many eyes, been pointed at an interstellar object. And yet nothing showed up. It sounds absurd, but the timeline made it worse. ESA's image drop lands with a thud. NASA's high-resolution HiRISE camera goes offline due to a government shutdown. China and the UAE release no data at all. Then, as if to twist the knife, amateur astronomers begin posting images from Earth, blurry but real, that seem to show more than what professional missions could. How do you lose a comet that's right in front of your face? October wasn't just any month. This was the lead-up to perihelion, the moment when 3I Atlas would swing closest to the Sun. The heat, the light, the pressure. This is when comets usually flare, erupt, or even break apart. It's the moment scientists wait for, because that's when you see what's hidden beneath the ice. Jets, fragments, trails. Something. Instead, just as 3I Atlas reached its most active and dangerous phase, the data flow stopped cold. Scientists still can't explain why every major high-resolution imaging attempt failed. So what really happened in those first 48 hours? Every camera fails, one by one. Right after the European Space Agency's blurry image hit the web, space enthusiasts around the world turned their hopes toward other eyes in the sky. 3I Atlas had the attention of the entire scientific community. It was the first interstellar comet to swing this close to Mars while the red planet was surrounded by orbiters from multiple nations. The first big hope was CASIS, the high-res color camera onboard ESA's ExoMars trace gas orbiter. It had been orbiting Mars since 2016 and had captured stunning images of Martian landslides, dunes, and even frost patterns on the surface. But CASIS wasn't designed for deep space targets. It was built to scan the Martian surface, not track objects racing through space tens of millions of kilometers away.
ExoMars, ESA is going to use for the first time a method called aerobraking for a spacecraft in orbit around Mars.
When pointed toward 3I Atlas, CASIS hit a hard wall. At that distance, each pixel on its sensor covered over 300 kilometers. That's like trying to take a portrait of someone using a security camera across the ocean. The comet, likely only a few dozen kilometers wide at most, was smaller than a single pixel. Even with perfect focus and extended exposure time, all the light from the comet would be smeared into a single speck. A blurry dot was the best it could physically do. ESA's lead investigator for the instrument later explained that just detecting the comet was a stretch. The team stacked multiple exposures, adjusted the tracking software, and tried everything to squeeze signal from the noise. The result was that now infamous image. It was not a failure in engineering. It was more a limitation of physics. The world had waited for this moment, and what they got was a glitch rather than a glimpse. Next, attention turned to NASA's Mars Reconnaissance Orbiter. Its onboard camera, HiRISE, is one of the most powerful optical imagers ever sent to another planet. It's capable of spotting a rover the size of a car on the surface of Mars. If anyone had a shot at resolving the comet's nucleus, or at least capturing a few crisp frames of the object's outer shell, it was HiRISE. But something strange happened. Just weeks earlier, the agency had posted regular updates on the upcoming comet pass. When the moment came, no targeting data appeared in NASA's public observation schedules. No new frames appeared, no image drops, no mission updates, no explanation. The comms line had gone quiet. No one outside the operations team even knew if HiRISE had attempted to observe 3I Atlas at all. The Chinese Tianwen-1 orbiter had been mapping Mars since 2021. It carried high-resolution cameras, spectrometers, and a radar system. Plenty of tools that, in theory, could have contributed observations of 3I Atlas. Yet no images or updates ever appeared. No press releases, no confirmations, not even a statement saying they attempted to observe the comet. The same thing happened with the United Arab Emirates HOPE mission. Despite being equipped with imaging hardware and positioned in orbit, it released no data, no commentary, no signals that it had even tracked the object. If it had just been one agency going dark, sure, maybe a technical hiccup. Two agencies. Could be a coincidence. But three, from three different countries, at the exact same time. That's when the pattern started to look less like chance and more like something stranger. Also because it's not like these spacecraft were busy. 3I Atlas wasn't just flying by in secret. Its trajectory had been calculated weeks in advance. The timing was known down to the second. All of these orbiters had the opportunity to point their instruments at a once-in-a-generation target, and none of them showed their results. It made no sense. Some online commentators offered explanations.
It's here, and the comet is here. The sun sends the solar wind to the comet, the sail goes behind the comet. Guess what? This comet is at the reverse side.
But is it nature or something else? We're gonna find out soon.
Maybe the cameras weren't built for fast-moving interstellar objects. Maybe the comet was too dim in the specific wavelengths the instruments used. Maybe observation windows were missed. But if that was true, why didn't any agency come forward to say so? Instead, the public was left in the dark. Here's the brutal truth. During the comet's closest pass by Mars, with at least 4 active orbiters in position, not one space agency released a single high-resolution image that showed any surface detail. Not one. If you believe that's all just bad luck, fine. But if you're starting to think this wasn't just a series of misses, that maybe something about this object made it uniquely difficult to capture, you're not alone. And the mystery was only getting deeper. The Great Image War. As the official mission stayed silent and the world waited for anything sharper than a blur, another battlefront opened online. Amateur astronomers, astrophotographers, and data junkies stepped up to fill the void. If the billion-euro orbiters wouldn't deliver, maybe a backyard telescope in New Mexico or a hillside rig in Italy could. And for a while it looked like they had. Starting the night of October 7th, amateur astronomers around the world began sharing their own images of 3 Atlas. Some were single long exposures, others were multi-frame stacks, carefully aligned and layered to reduce noise. A few went all in with AI-enhanced filters, claiming to extract structure and detail the naked eye couldn't see. One of the most viral sequences came from a comet tracker in Melbourne, claiming to show surface structure. Professional astronomers pushed back. They explained that when you stack faint frames with imperfect alignment, random noise can start to look like structure. Cosmic rays, hot pixels, and even background stars can smear into shapes that trick the brain. In one demonstration, identical raw data processed with different settings produced 3 completely different comet shapes. Especially when you want to see something, the mind fills in what isn't really there. One thread showed how the same stack of data, depending on processing settings, could look like a blob in one case and a detailed object in another. It wasn't a matter of data quality, it was a software illusion. Some of the best amateur images came from observatories using telescopes under half a meter wide. While impressive, these were still limited by atmospheric distortion and signal-to-noise problems. AI tools helped clean up some frames, but they also added artifacts. Sharpening filters created crisp edges where none existed. Deconvolution algorithms sometimes doubled faint objects, introducing phantom details that looked eerily real. Meanwhile, the professionals pointed to math. At a distance of 30 million kilometers, and with even the best ground-based amateur gear, the nucleus of 3Y Atlas would be far smaller than a pixel. You couldn't see it. At best, you could detect its presence through the coma, the cloud of gas and dust surrounding the comet's core. But any sharp core seen in a photo was likely just the brightest part of the blur. Still, the amateurs persisted. They started compiling side-by-side comparisons. One particularly viral post showed ESA's official Cassis image next to a suburban telescope's result from Missouri. The amateur photo had more contrast, a brighter core, even a suggestion of a tail. The caption read, "What are they hiding?" Scientists scrambled to explain. The Cassis image wasn't designed for brightness. It was meant to confirm detection, not deliver glamour shots. And unlike amateurs, they couldn't use uncalibrated enhancements. Scientific integrity required raw data and standardized methods. That made their results look dull by comparison, even if they were technically more accurate. But that argument didn't win hearts. It didn't go viral. And it didn't stop the growing belief that space agencies were downplaying something weird. The deeper the image war went, the murkier everything became. Everyone was working from the same few pieces of data, but each side had a different story. One saw the comet behaving normally, just too distant to image properly. The other saw intentional obfuscation, strange emissions, and movement that didn't match known patterns. In a way, both sides were right. Amateur data often did show more contrast, but it wasn't necessarily more accurate, and official missions did have technical limits. But they also had communication failures, data delays, and unexplained silences that fueled suspicion. By October 9th, the internet was split into two camps. One that believed they were witnessing a cover-up in real time, and one that believed people were seeing things that weren't there. Then radio silence. While people argued over blurry pixels, sharpened filters, and missing images from space agencies, a few scientists shifted their attention to a different question, one most people weren't even thinking about. If we couldn't see 3I Atlas clearly, could we at least hear it? Radio astronomy doesn't depend on light. It listens for electromagnetic waves. That includes natural bursts, gas emissions, or even artificial signals if they exist. It was radio that first detected pulsars. It's radio that still tracks the faint pulse of Voyager. And it's radio that can help us understand how comets behave as they heat up. As comets near the Sun, their frozen gases begin to sublimate. One of the key byproducts is hydrogen, and there's a special frequency, 1420 megahertz, known as the hydrogen line. It's been used for decades to study everything from star formation to comet composition. If 3I Atlas was becoming more active as it neared the Sun, it should have been emitting detectable signals along that line. But during its closest pass to Mars, no public observatory released radio observation data. None of the major research centers, not NASA's Deep Space Network, not any university telescope, shared results from scanning the hydrogen line during that window. And that's the strange part. You don't need billion-dollar infrastructure to check the hydrogen line. Amateur radio astronomers do it all the time. There are open-source tools and even backyard arrays that can sweep that frequency. But this time, nothing surfaced. No spectrum charts, no signal plots, not even a posted confirmation of silence. It wasn't just that we didn't hear anything. It felt like no one even tried to listen. Around the same time, something else stirred confusion. A Perseverance navigation camera captured a streak on October 7th that some believed lined up with the comet's trajectory. But without the original metadata from the image's FITS headers, the raw file that includes exposure time and sensor settings, it was impossible to say for sure what the streak really was. If the photo was taken during a 10-minute exposure, the timing and direction matched the known path of 3I Atlas. But if it was just a 1-second snapshot, that would change everything. The object that created the streak might have been something entirely different, possibly even something in Mars orbit. That one gap in the data turned a boring engineering frame into yet another layer of mystery. So here's where things stood. 1. No space agency captured a clear, detailed image of 3I Atlas. 2. The amateur astronomy world split into two sides, one claiming discovery, the other crying distortion. 3. No public radio observations were released during the comet's Mars pass. 4. A strange streak appeared in a Mars rover image, but without full metadata, its identity remains uncertain. 5. The comet's behavior became harder to track as it accelerated and dimmed heading toward the Sun. And now, it's about to disappear altogether. On October 29th, 3I Atlas will enter solar conjunction, a period when it passes directly behind the Sun from Earth's perspective.
The problem is we can't observe it from Earth because it's on the opposite side of the Sun. So when you look at the Sun during the daytime, right now, the 3I Atlas is flying behind it.
That means for at least 40 hours, no Earth-based telescope can safely observe it. The Sun's glare overwhelms everything. Radio instruments risk interference, optical trackers shut down to avoid damage. For that brief but critical window, 3I Atlas will be completely invisible. And depending on what happens next, it might not come back the same. What are we looking at? By the time 3I Atlas had passed Mars, vanished behind the Sun, and reappeared as something no one could agree on, one question sat heavy over everything. What exactly are we looking at, and why does it seem like we're not allowed to see it? We're dealing with an interstellar object, not just any comet, but one that came from outside our solar system. Already, that makes it rare. Only 2 others have ever been confirmed: Oumuamua in 2017 and Comet Borisov in 2019. Both had strange features. Both challenged existing models. But 3I Atlas is the first to pass this close to Mars, with this many instruments positioned to observe it. And somehow, despite all that tech, it avoided being captured in detail at every single turn. That's something no one has fully explained. Now we have to ask the question no one wants to be the first to say out loud. Is this just a mess of failures, technical, bureaucratic, maybe just plain accidental? Or did we just try to observe something that defied everything our system was built to handle? Let's lay it out clearly. 1. The first image from ESA was a pixelated blur. 2. NASA released no high-res images, no tracking logs, no data confirmations, despite having the most advanced high-resolution optics around Mars. 3. China and the UAE, both with operational Mars orbiters, released no images and made no public statements. 4. Amateur astronomers saw more than anyone expected, but their results stirred more argument than answers. 5. No radio-based observations were released or confirmed during the most important window. 6. The Perseverance rover's only relevant photo showed a single, unexplained streak that may or may not have aligned with the comet's projected path. That's 6 separate events, and each one on its own might have been explainable. But all 6 happening during the closest pass of an interstellar object, that's what people can't shake off. This was supposed to be the moment when science made a breakthrough. Instead, what we got was crossed wires, quiet feeds, and instruments that, for one reason or another, couldn't deliver. And here's the part that makes it more frustrating. No space agency has issued a press release calling this unusual. No major research group has stood up and said, "Something went wrong here." Officially, there is no story. But outside those walls, online, in forums, in amateur astronomer circles, people are talking. And the same theory keeps circling back. But maybe the real answer is simpler and more unsettling. What if our current planetary observation systems simply weren't built for this kind of object? What if each group was waiting for another to lead the effort and the result was silence by default? 3. I-Atlas isn't acting like a normal comet. Not in how it appeared, not in what it avoided, and not in the way it left behind confusion instead of discovery. But even if the data eventually comes, even if we get the detailed report, the diagrams, the calibrated snapshots, it won't change what already happened. I-Atlas revealed something most people hadn't realized. Not just about the limits of our technology, but the limits of coordination, urgency, and response. It showed us that even with multiple spacecraft, international missions, and round-the-clock telescope coverage, we still don't have a system that can respond fast enough to an unknown target. In 2025, with machines orbiting other planets and AI tools scanning every pixel, we still managed to fumble a comet flying right past our face. And that's the most disturbing part of all. Thanks for watching. See you in the next one.